ISS a couple years ago, accidentally. The Russians' cargo ship fired its rockets, and the space station rotated and the antennas were upside down, right?
Hey, this is James, November Zero Whiskey Radio Lima, and I'm here with
Randy Berger.
And Randy is with APRS, or Amateur Radio on the International Space Station. Randy, maybe you could tell us a little bit, what is your role within APRS?
Sure. So I'm the Director of Engineering, and I help with and oversee the new equipment that we send up to the International Space Station today. That includes radios and software for amateur radio. And today on the space station we have two different segments. We have the Columbus segment that has our crossband radio inside of it that does 70 centimeters down and 2 meters up to it. So we do a crossband link with that. And 6 times a day, folks get to talk through that. And then we also do APRS and slow scan TV. And that is over in the service module on the Russian side. And so most of the time it's in the APRS mode, sending messages and so forth, and people communicate several times a day with that. The other part is that we are working toward being enabled on other spacecraft. And so being enabled on other spacecraft, what does that mean? So in the past 6 months, we got qualified on Dragon from SpaceX to fly the 705, and Rebea use this to communicate with children. And
so this is actually a 705 radio, just like this one, is actually what was deployed on Dragon.
It was actually. You know, it was kind of surprising, I think, to us last year when that was brought up. And we have, APRS has a community, an international community, and Rebea is from Germany, and she's working on her PhD, I believe, in Switzerland. And this was the radio that she chose, and so it was something we've never used. So it was like, okay, well, we're shifting gears.
That's awesome.
And the neat thing about this was we were able to interface our software with it. So I came up with an idea because they wanted us to run on battery power with the radio itself during their mission. So the mission basically was to go over the poles and communicate with children at different schools as a contest, and that was a lot of fun for everybody. But we were limited to battery power, right? And at first we only had 50 watts, and 50 watts would only last 3 hours out of a 4-day mission. So that was really short, right? And so what we did was I came up with the idea to geo-fence, and we'd only transmit and turn the radio on over land. So over the oceans, 3/4 of the Earth is covered by oceans, and so we would have the radio off during that time. So we enabled that, and fortunately, working with SpaceX, they finally granted us to have 3 batteries instead of just 1, and that helped a lot. So
I'm sure, but I mean, if let's say a third of the time, or whatever it works out to, the Dragon capsule is actually over water, you're basically, or I guess 2/3 of the time, you're saving essentially 2/3 of your battery by the geofencing technique.
That's right. That's right, yeah. So that helped us a lot. That extended us basically to 9 hours of work with it, right? So that was actually really good. So the geofencing, turning it on and off. The radio was transmitting only at 10 watts, but as the battery depletes, it goes down to 5 watts actually. And when we got invited to be and to help with FRAM2, the question was, what type of antenna do we use, right?
Right.
And everybody had ideas, everybody, right? and they range from, there's a little window on Dragon that they could look at, right? We could use a rubber ducky up against that, or we could mount another antenna on that. And then
we're very space constrained as well, too.
Yeah, space constrained.
No pun intended.
No, you're right. Some suggestion, and we don't have it here, an arrow antenna that's like about this long, right? And that would have never fit inside that capsule. So
how big is the Dragon capsule?
It's about 20 feet in diameter on the outside, and it's a lot smaller inside, right?
Yeah. So that is still bigger than you might think.
Yeah. So this fits 4 crew, right? So there's 4 crews sitting side by side inside of it here. So probably inside the interior is probably maybe 10 feet across at the most.
Wow. So you had the FRAM2 mission where you actually deployed on SpaceX, which congratulations, by the way. I mean, that's just incredible what you guys have done with that. And I think those types of exciting missions, I mean, when you guys are getting great wins like that and actually getting amateur radio deployed on SpaceX, that is just freaking cool. You've got, of course, the International Space Station. We can dig a little bit more into the equipment there. Are there any other missions that you guys have done recently, or any other equipment that you've deployed that you think is, you know, worth a mention?
So absolutely. So we actually are deploying DVB-S. We call it ham TV, and that's being deployed up on the station here next month.
Ham TV.
Yeah.
Okay. Nice.
It's
I
called
love
ham
it.
TV.
Hey, well, it's easy to remember. Ham TV. Okay.
Right. And so we had it up on the station back in 2015-17 era, and unfortunately it got broke, and we had to bring it down. We call it down mounts, and we brought it down. We fixed it, sent it back up, and it is now going to be deployed next month by the astronauts. And so what the purpose of it basically is to use video to send and talk to students at schools and so forth, and other amateur radio operators. So,
wow.
And this is a receiver. This is called Pico Tuner. This is actually from the British Amateur Radio Television Group over in the UK, the BATC.
Okay.
Very, very cool. It's a package that you can drop a bomb into DigiKey. 3 to 5 days later, you get this box with all the parts and everything in it, and for about $70, $80, you can have the receiver put together. So that's the receiver. You still need an antenna, but that will get you up and running with it. So that's actually pretty cool.
No, that's really, and so I'm familiar with slow scan TV, and one of the things we're doing is doing some more training on getting people to receive slow scan TV images from satellites and things like that. But ham TV is a little bit of a new concept to me, and I'm sure to many others as well. So how does ham TV differ from SSTV as far as, obviously, the equipment that you have to use? Maybe you could tell us a little bit more about the protocol and the bandwidth and how, I mean, just give us the high level of, you know, how that differs from SSTV.
So when we're using slow scan TV on the ISS today, we're using PD120, and that means it's transmitting every 2 minutes, right? But what it transmits is audio files, and so it's transmitting audio files. So if you see this up here, this is an audio that's coming down from this, so it's basically audio that's being looked at.
So cool.
Yeah.
So cool.
And amateurs worldwide use this every day. If you go down to 14,230 megahertz, you can listen to slow scan TV messages on that. Now,
and you can do that anytime.
Every day.
Listen, 14.230 megahertz, and you can listen to SSTV.
You'll see QSL cards, pictures people are sending all the time. It's very, awesome. Very awesome. And but we use this on the space station too. In particular with FRAM2, we use a different protocol. We used what we call Robot 36, and the Robot 36 transmits a 36-second image, and then on FRAM2 we had 36 seconds off to let the radio cool off, right?
Okay.
Then it would transmit 36 seconds in, 36 seconds off. Here we're transmitting it a lot faster because I've got the wattage to turn way down on it right now.
Right.
On the digital side of it, right, so we're moving to kind of like a DATV, if you remember how the DATV is.
Right.
So that's high resolution video, right, but it's all digital, it's not audio. And so the digital messages are coming down, and we're using DVB-S. The current method is DVS-2, but the equipment up on the space station was invented and put together by ESA back in it was developed around 2012, right? So the technology really wasn't there for DVB-S2, but we will have DVB-S2 in about a year. This package here, right here, which we're going to send up, we'll be able to send DVB-S2 also, but it is also our sensor system. So a couple years ago, NASA National Labs gave us a grant along with the University of Berkeley to develop a sensor system for children, and we would send back the information on telemetry back down on an amateur radio frequency. So what we would do sending the message down is today the ISS is using a crossband link, and that crossband link is basically using 70 centimeters down and 2 meters up. We're going to take the 70 centimeters and we're going to send the data under voice.
Right.
So as everybody is talking using the ISS as it comes over, under voice and the subtone, we're sending telemetry, which will have the temperature, humidity. It's got like 12 different sensors on it, but it includes every type of gas. Any type of gas you can think of, it'll be able to detect. Light, ultrasonic microphone in it to listen to the space station to see what noises and creaks are going on inside of it.
And that's something that any amateur radio operator can receive and decode?
Yes.
Yes.
So today they have FM receivers that are receiving it, and that data is there coming underneath of it, so they'll be able to decode it too. So we're going to send it to a server, and so schools and amateur radio operators or whoever wants to can use that data too.
Yeah, maybe you set up yourself a little dashboard and track the telemetry on the International Space Station. That would be very cool.
Yeah, the purpose was to set up a virtual mission control, right?
Yeah.
So the University of Berkeley started working on the concept, and they have the panel for it. This is pretty promising for us because it can not only be used on the ISS, but we can use it on other commercial space stations too. We can use it on VAST, we can use it on Axiom, we can use it on Orbital Reef. So this is going to be pretty cool.
That is
plus all of our radios.
And so you told us about the Dragon mission, you told us about the ISS, we talked now about ham TV. This will be deployed, ham TV is going to be deployed on the International Space Station.
It is, yeah.
Are there any other missions, or do you have any more plans with SpaceX or any other?
We do actually.
Yeah.
So with SpaceX in particular, so we're certified on Dragon now with our equipment. I think the benefit to the amateur radio community as a whole is that there will always be a Dragon pretty much at this point in time connected to all the new commercial space stations. Mm-hmm. So like the next space station going up will be, well there's two, but will be VAST first, so Haven 1 will be going up, and the astronauts to do any work will be connected to it all the time. So we're hoping, and the plan is, and we're working with VAST, and we're working with SpaceX, and they both have kind of tentatively agreed that, hey, we want to work together. So we'll have radio on VAST space station, which will be the next space station going up. Following that is Axiom, which will be connected to the International Space Station, right?
Wow.
And that will also have Dragons connected to it too. We are working with Axiom to possibly do an on-orbit transfer of all of our equipment off of ISS over to Axiom Space Station, which will be really cool.
Wow.
Yeah.
Could you tell, for folks who aren't familiar, just tell us a little bit more about Axiom, what it is, and yeah, just I guess the quick overview there.
Yeah, so Axiom is a company based in Houston. They're actually doing two things. They're doing not only the new space station for ISS, but they're also doing the spacesuits. So NASA has given them $2 billion to do the spacesuits and an IDIQ for the space stations, and so they're putting these segments together, and the first segment will be attached to the space station, and then when we get ready to deorbit the space station here in 2030, hopefully, not earlier, Axiom will be released from the space station, and then they'll start building more modules onto it, and it'll keep expanding, and so it's going to be as big as the space station, basically.
That's incredible.
VAST is similar, except for they're taking a more smaller route. They're taking a single containerized space station first, and then that's called Haven 1, and then Haven 2 follows that in a couple years, and Haven 2 will be put together as modules, but it'll look like a round orbital type space station, and it'll may have gravity.
This is incredible. I mean, it's amazing to see all of the things that are happening in space over the next couple of years. But not only that, the big role that amateur radio and the work that you guys are doing. I guess just to kind of take a step back here a second, why? I mean, clearly you and the others see like a huge value in amateur radio and the work that you guys are doing. What do you think is like the big tie-in, and why do you think amateur radio is so important to have on the ISS, to have on missions like Dragon, and to continue to engage with APRS? What is it that I think is really catching people? So
for the amateur radio community as a whole, it's a hobby, right? So it's actually benefiting the community as a whole, right? But it also benefits, at least from the APRS standpoint, STEM education. That is what we are focused on with STEM education. From the space stations and the different agencies that are working with space, they see the benefit of our backup with it, right?
Right.
Frank and I were down at Houston this week meeting with NASA and also with Axiom, and our talk with them and with us basically was the benefits of APRS, right? And education is like number one kind of with us. But when we started talking about backup was the number one thing for them. And the reason backup is important is that we are connected to the world, and basically if anything happens to the space station, we're not connected physically to any of the functions of the space station. So amateur radio is there to help. And proof of that benefit, what happened in the past, Mir space station lost contact for several days. And the only communication Mir had was amateur radio.
It was amateur radio.
And the space shuttle, we've done some tests with that too, and we've actually shown how we are back up on the space shuttle also. Then the ISS, a couple years ago, accidentally, the Russians' cargo ship fired its rockets, and the communications for the ISS basically is from satellites above the space station, and they're called TDRS. Well, the space station rotated and the antennas were upside down. right? Well,
They fired the rockets, which caused a rotation.
rotated the whole station.
Wow.
And for 90 minutes, they were out of contact with the station, right?
That seems like not a lot, but that's scary. To be out of
pretty
contact
scary.
for 90 seconds, you're saying, am I stranded here?
Yeah, right. They sent not only amateur radio operators to Kennedy and Johnson and Goddard. We had people in there. Then we had full of NASA people too, right? So we had backup. It was backup for them, right? And so the new space stations, a lot of the folks at the new space stations, the VPs, are ex-NASA folks.
Wow.
So they understand the benefits of amateur radio.
And many, I mean, from talking to our colleagues here, I mean, we're talking probably about 50% of astronauts are licensed amateur radio operators as well.
That's right.
Yeah. And so, I mean, I think what you're saying has so much merit. I mean, because when you're sitting here and you're showing me, you know, the decoding of SSTV, and you're showing these things in an amateur setting, I think one of the big differences between a commercial setting is that this is something for somebody, whether it's a student or whether it's a lifelong learner who's trying to learn about the fundamentals of the technology, being able to do it in an amateur radio setting, you can get hands-on in a way that you just can't with commercial radio. So you can truly learn the technologies, and you can understand how images are decoded at a base level. You know, if I pull out my iPhone and I send an image, it seems like magic, right?
Right.
But what's actually happening in the background is you're just encoding information. You're sending it over, you know, the airwaves on a different protocol in this case. But it's the same thing that we're doing with amateur radio.
It is the same. And you know, amateur radio actually helps too. We pioneer a lot of development in digital communications, and so right now we're doing some new things. Phil Karn has some new software out that will take a group of frequencies and basically kind of like a waterfall, and basically encodes those into a digital package, right? And it sends it down a single pipe. So what that means for us on the space station, which we're going to be using here in the future, basically, is we can listen to multiple FM frequencies or sideband or whatever, but let's say, and everybody could be talking to the ISS or to their friends, and we're sending it down on another pipe that's coming down, let's say, that's a single frequency, and then the receivers are all decoding that, so they can talk to whoever they want individually, similar to the way the cell phones work today. And so it's something new, and so we're actually having fun with new digital technologies.
And so you could foreseeably see where you could develop something exactly like what you're talking about, and then the technology could be translated into commercial or other space applications.
Absolutely, yeah, absolutely. Yeah, we're doing that to the moon too. We actually were down selected on a grant to, December of this past year, NASA came out for a grant for Artemis 4 to have an astronaut take a package and place it onto the lunar surface. And so we were invited for that, and that was really cool. So we submitted for the grant, and we were down selected. So what that means is there was thousands of people that submitted for this grant. It was a $25 million grant.
Wow.
Right. And so we were down selected to basically less than 10. And so we're waiting to see where that's going right now, but we may have opportunities.
You got it.
We're hoping so. I don't want to get too excited, right? But we're hoping for that. And anyway, the experiment basically, we're working with a couple universities down in Florida, and we're amateur radio packages using the 5 and 10 gigahertz transmissions with it. So that's amazing.
Cool. So I guess what would you say? Any tips for, let's say, new hams? They're hearing this. They're interested in, they're interested in the work that you guys are doing with APRS, amateur radio on the International Space Station, any of your other missions. And what tips would you have for those folks about how they can continue to learn or potentially get involved?
I would start with trying to listen to the space station. The space station today, out of all of the things that's flying in space at this point in time, at least for amateur radio, has the strongest signal coming down, right? So it's very, very easy to hear, and it flies over, like here in the US and most of the countries, 6 times a day. So you could go out once or twice, maybe a day or afternoon or evening or something like that, and be able to hear the ISS, right? And maybe you can share it with students if you're associated with a school or something like that. Share it with students, because we need the younger generation to get involved, right? It's very, very important with that. I mean, we see that there's myself that's got gray hair and other folks, right? But it is very important for us to have the younger generation involved. And to that fact, NASA actually helps with us with having students during the summer, right? Student interns. And I've been very fortunate the last few years to have student interns, and basically I try to select students from different universities across the United States, and I bring them in and help them with that. I've got 2 of them right now, which is really impressive, and I'm thankful that they're on. We had met last year, and they were part of another organization and we went to go present up at Goddard, right? Yeah. So I invited those 2 students to come in and join APRS, and now they're part of it. But one of them is going to go to work for Blue Origin this summer, and another one's doing an aerospace, and so we're actually helping kids.
And and that's not something that's a maybe or a might be. I mean, you're actually seeing student interns go and work for some of the most innovative space companies. I mean, you guys should be so proud of that.
We're really
so proud of that.
Yeah.
I think that there's no question that space exploration is just one of those frontiers of humanity, and you guys being a major part of that, both on the education side, both on the actual implementation of these backup communications. I mean, you're just doing incredible work all around.
Yeah, thank you.
Well, thank you so much for your time. I appreciate it.
Appreciate it. Yeah.
We've helped over 60,000 students get their US FCC amateur radio license, and we can help you too, no matter your age or educational background. Go to www.hamradioprep.com and try a free lesson today.